For this lab, I designed that the registers are updated by clock, positive clock. So I did two ways, but I just find that the updated by clock is just easier to understand. So the switches, buttons, they are updated only when clockwise. So if I press the reset or the load, it will update the data. No, sorry, it will update the input during the clockwise. So everything is clocked, so synchronous basically. I do this, press, boom, change. Same, it gives me the same result as using load. When press load, when detecting load, then it will update the input and then output. I receive the same result. Okay, this is the part A of assignment 2 or lab 2. I use the main clock, feed them into the module clock ladder that will produce the pin 17. I use pin 17, which goes to the controller, and that controller will be the one that's keep switching the selector of the hex. So it will just keep going from 0, 0, 0, 0, 1, 1, 0, and then 1, 1. It will just keep switching and then updating the hex. So here I have the reset button. So when I press, it should go 0. If I release, let's go back. And those are the switches. Now these switches, buttons and the buttons here on the flipboard, these are like registers. They basically will receive the new input only when I press load. Otherwise, it will just keep the old input and then it will just keep sending the old input to the hex. So if I move this up, boom, I press update, now it will receive a new input and then it goes to the hex. Okay, for the system design, I just follow the diagram on the instructions with a little twist. So instead of, I don't know if I'm supposed to pause the clock ladder from incrementing the output, but I did that and it doesn't work. So instead of stopping the clock ladder, I paused the binary counter when I press the on-off toggle, which works as expected. And when I press reset, it should roll back. Yeah, so that's my design. And then once the clock ladder produce the new clock, I just have the pin 22 into the binary counter, and then pin 17 of the clock ladder, the result of the clock ladder, to the MUX decoder and controller. So for the MUX controller, I saw on the diagram, I'm not sure if I did it correctly, but I didn't modify the code of controller from part A, and then I didn't modify the code of decoder, but instead I have a new module which calls 2 of those modules inside of it, and then I have my top level calling the new module. It looks like a nested modules basically, but it works. Yeah, this is what I did. And then all the reset will goes to all of the module, like the binary counter, MUX, and then also the clock ladder as well.